Class, this is a continuation of the video conference that I delivered last night, Wednesday, April 25th for 143, week 4. This is code that you should have had from week 3's video conference that includes the classes vehicle and car. And vehicle, we added a print color as a polymorphic function here. So this print color can print the color of a car or a vehicle. And but I've added a couple of new things. So in addition to the code you've written so far, I want you to write these lines here. Actually, before we do it, let me just take a quick look at this example here. So I'm not going to have you write this, but I was trying to explain to the video conference what a real-world analogy of polymorphism is. And that is what I would say Jiffy Lube is an example of real-world polymorphism. Jiffy Lube is a company that doesn't know anything about how to build a Ford or a Toyota or a Mercedes-Benz. They don't know how to service all those different things that are unique to those cars, but they do know how to change oil. And so in this example, Jiffy Lube is like a polymorphic organization. Okay, they can handle any type of vehicle, whether it be a car, truck, SUV, a Honda, a Toyota, whatever. And all it needs to know is that there's a way to drain the oil out of a vehicle, there's a way to change the filter on a vehicle, there's a way to reinstall the oil bolt on the vehicle, and there's a way to reinstall a new filter on the oil on the vehicle. So each vehicle would need to be responsible for implementing these functions. Okay, but Jiffy Lube doesn't have to know how to implement any of those. So for example, the torque specifications on a bolt of a Honda is different than on a Toyota. Okay, that's for Honda and Toyota to figure out. But Jiffy Lube just needs to know that there is some sort of a torque, and that we're gonna do that when we reinstall the oil bolt. Okay, so that's a real world example of what polymorphism is. But let's go back to this example here. So I want you to write this code here. So we're going to create a new car, and this car should be the identical information as a previous car. Okay, and then we're going to run this code to see, is C1 equal to C2? So are the two cars equal? Okay, so we're going to run this code, and down here you can see that it failed. And why did it fail? You remember from 142 that the only thing that this equals does is to see if they are the same object in memory. Okay, so if I said car C2 equals C, then this would be true. In fact, here, let's just quickly do that. C2 equals C. Okay, let's run it. And now it worked. Okay, that's the only thing that equals does, because that is implemented by the object class, from which all classes are subclassed, and the only thing it knows about is that there's a piece of memory out there. And so that's the only thing it can check. So the question is, how do we make the polymorphic equals code work for our class? So even though we don't say that this extends a class, it actually is implied that all classes extend the object class. And one of the features of the object class is a method called, I'm going to override, it's called equals. So public Boolean, because it has to return whether it's true or false for equals. And then let's try putting in a vehicle V. And we've got an error here. Let's take a look at the error. It says the method equals vehicle of type vehicle must override or implement a supertype method. So it's saying, well, we're supposed to override a method, but this isn't the right method. The reason why this isn't the right method is because in the object class, that when you override something, it's got to be the exact same declaration. And in the object class, it takes an object. And so we actually have to put object there. And we've got an error. It says overrides Java lang object equals. That's good. This method must return a type of Boolean. Okay, so we just have to fill out the body of this. So what does it mean for two vehicles to be equal? Well, let's look at the member variables for vehicle. There's a make, model, color, and a year. Okay, so ideally all four of those things have to be the same. So let's First of all, so I'd like to work on the vehicle class, but I can't work on the vehicle class until I actually check to make sure that this object is a member of the vehicle class. So let's put if O instance of vehicle. In that case, we can do a vehicle v equals, and we're just going to force this. We're forcing O to be a vehicle. And if it's not a vehicle, then we're going to return false. Okay, but if it is a vehicle, now we can check. We got 4 things to check, right? So if the this dot year, actually let's use the proper thing. Let's use this dot get. Should be a get year here. It's not coming up, but yes, get year equals the v dot get year and this dot get make equals v dot get make, and this dot get model equals v dot get model. Oh, you know what? We can't do that either. What's the problem? This equals isn't going to work. It's going to have to be dot equals of the v dot make. Because if we used equals, we'd have the same problems, that it would only check if it's the exact same piece in memory, and it's not going to be. So we've got to use dot equals for string. And what do we have left? This dot get color that equals v dot get color. Okay, so that, and actually we don't need an if, we can just return. Okay, so that's going to test all 4 of these things. Let's check and see if that code, remember that code up here, if C is equal to C2? Let's see if this worked. Okay, so we're going to see if that worked, but we've got to change this now. I'm going to duplicate this code here. Okay, so we're going to place the second one here with now a dot equals. Equals there. Okay, so we're going to run this now. Okay, so we see equals work failed, but dot equals worked. Okay, and let's just out of curiosity see what happens if I go into that dot equals. Should have just wrote here. What happens if I comment this out? Okay, so now I've removed the dot equals, and let's run it. Dot equals failed. Yeah, okay, because it's going to just default to the object's behavior. So that is how we write polymorphic code. Now, the truth is that what I wrote here is actually too simple. There are certain cases in which this can fail, and there is a way to fix that. Actually, let's go back to commenting. No, it's not going to let me do that. Okay, let's comment this out again. And let's instead try this. Source. Generate hash code and equals. Okay, and then let's take a look at what it generated for equals. Okay, so first it checks if the actual superclass object is true or is the same or not. That's the superclass test. Then it checks to see whether one of the objects is null. Then it checks the classes. Then it forces it, which we did. Then it checks if the color is null. So it's checking for null strings. It's checking if this is a null string, if that's checking a null string, if that's checking a null string. So this is actually what's necessary. But you can see how our code, assuming that our object was set up correctly to have non-null of all of those, this actually worked as well. So that's an example of how polymorphic code works. Now, this example still might seem rather shallow because, okay, great, now we can check whether two objects are equal. But this actually enables several things that are very complex to do normally. Here, I've added some new code here to deal with array lists. So array lists are the topic of chapter number 10, and the reason why I jumped to array lists because the primitive arrays don't have an index of feature, but the array lists do, and it's only a feature because classes implement an equals function. So I've created an array list of vehicles here, and then I added car C, and then I added vehicle V. And by the way, I unintentionally, or somewhere along the line, I had originally had vehicle V being a vehicle, but somehow it changed to car. So to show polymorphism, I changed it back into a vehicle. So these are, one's a subclass of the other. So we've got two different classes in this array list now, both vehicles, but the car C is actually a car. And we've got equals, and so let's see what happens when I run this here. Okay, so it came up as -1 for the index of, and don't be surprised because we actually commented this out down here when I was doing this. So let's uncomment that out. Okay, so now there's actually an equals routine, and in fact here let's set the breakpoint. Let's take a look. Debug. Okay, we're gonna step down here. Okay, we're gonna do the equals. Then we're going to do the dot equals. This is actually going to step into this routine here. And so this is, let me just step over this and return because this isn't the important part. So this is true, and so it says dot equals worked. But now watch what happens when so I've added these two, and then I'm going to try to step over this index of, like I don't care what happens. But because I've set a breakpoint in equals, it actually shows me that it's actually calling the code here. And let's step over one line and then let's list here. Okay, so this is a silver Nissan Leaf Uber Black, and the V is a silver Nissan Leaf Uber Black. So this should return true. So you can see index of is actually calling our equals code. So now when I finish this, the printout shows that it's actually element 0. And here, let's make sure that it wasn't just a fluke. Let's reverse the order of these. So now let's run this again, and now it's coming back index 1. So that only works because we implemented equals in the vehicle class. Okay, so that's another example of polymorphism. And as we go forward, we're going to see that these Java classes not only implement index of, they also implement sorting. And in order to do sorting, we have another interface that we have to override, which is called compare to. So we'll get to that later. But this is an excellent example of, finally, what is the value of having these inheritances and these overrides and polymorphism? The value is that we get a function for free, okay? All we did is we created the car class and the vehicle class, and we taught it how the car class, what the members are and whatnot. But as soon as we taught it how to compare using equals to vehicles, that works for not only vehicles but also cars, and it now allows us to do index of. So now you can start to see the power of object-oriented programming, okay? Because we didn't have to know anything about how to find index of. It's not a hard feature to write. But when we get to sort, that's a very difficult feature to write. And all we have to do is just be able to compare two objects. So hopefully that gives you a better sense of what polymorphism is about and what the value is. So for your makeup work, I want you to take either take your vehicle code that you wrote from last week, or you can use this same one to start your own. And then I want you to add on this. So you're going to need to do the array list here. You're also going to need to import Java util. So create your array list, adding the two elements, printing out the index of, and in order to do that, you're going to have to implement this override of equals to get these values. I wanted you to do it by hand, even though I've shown you that it is possible for Eclipse to auto-generate. I want you to do it by hand so that you understand how this works. And it's also showing an example of how to use instance of, which is covered in the chapter as well. So do all of that, put it into this one file format like this, and then you don't have to worry about the Jiffy loop. That was just to illustrate things. And then submit that to me. Thank you very much.